So we're going to look at standard deviation. And standard deviation is a measure of the variation in a set of data. And it's represented or calculated by this formula. S equals the square root of the sum of x minus x bar all squared divided by n minus 1, where n is the number of values in our set of data. So the first thing we have to do is we need to find the mean. And mean is represented by x bar. Mean is average. It's the total of the data set divided by the number of values in that data set. Then the second step is to work out the difference between each of the values in our data set and the mean. So we do that by doing x take away the mean. So we're doing the inside of our bracket. Then we're going to square that bracket in order to make all the terms positive. So we've now got our x minus x bar all squared for each of the items in our data set. And we now need to total that column. This symbol here means sigma, and it means the sum of all the numbers. So we're doing the sum of x minus x bar all squared. And then we're going to substitute it into the formula and solve. So we're taking that number, the total of the column, and that's going to be the numerator. Our denominator is going to be n, the number of numbers in our data set, take away 1. And once we've got that fraction, we're going to square root it to find our standard deviation. Now we can leave it as a surd if we want an exact value, but most of the time we would be rounding it so that we can then compare it to another standard deviation for another set of data. So let's look at an example. We want to find the mean and the standard deviation of the following data. So the first thing we want to do is we want to work out what the mean is. And the mean, x bar, equals the sum of all the numbers. So if we imagine that each of those numbers is x, and we're using our new sigma symbol, so we're going to find the sum of all the x values, and we're going to divide that by the number of numbers that we've got. So n for this particular set of data is 5 because we've got 5, 12, 14, 18, and 21, 5 values. The sum of those values comes to 70. And we're going to divide that by 5, and that's going to give us a mean of 14. So we're going to take that information, so n equals 5, and our mean equaled 14, and we're going to complete the steps in our table. So first of all, we're going to write in our x values. So we've got 5, 12, 14, 18, and 21. And it's useful to put them in order from smallest to largest, particularly if you've got quite a lot of data, because that way, if you have a repeating amount, you don't have to repeat the calculation when you're filling in the other columns. Then we want to work out what our x minus x bar is. So we're working out the x value and we're taking away 14 from each of these values. So 5 take away 14 is going to give us negative 9. 12 take away 14 is going to give us negative 2. 14 take away 14 is giving us 0. 18 take away 14 gives us 4. And 21 take away 14 gives us 7. And that's telling us the distance away from the mean each of our values is. Now we need to square it to get rid of all those negatives. So negative 9 squared is positive 81. Negative 2 squared is positive 4. 0 squared is 0. 4 squared is 16. And 7 squared gives us 49. Now, if we remember back to our formula, so I'm going to write our formula down now. We've got S equals the square root of the sum of x minus x bar all squared divided by n minus 1. So we need to do this sum of x minus x bar squared so that we can get a total to be our numerator. And so we're going to add 81 plus 4 plus 0 plus 16 plus 49, and we're going to get a total of 150. Then we already have our n value to substitute into our denominator. So now we can substitute everything into our formula. So we're going to get s equals the square root of 150 over 5 take away 1. And that gives us 150 over 4. And as a third simplified, that would give us 5 root 6 over 2. But we're going to round that. So our calculator will give us 6.12 and some change. And so if we round it to one decimal place, it's going to be a standard deviation of 6.1. Now, in this example, we've got a fruit market that takes place at one weekend, and the number of visitors to 6 stalls was recorded on both days. The mean of the number of visitors and the standard deviation was calculated for each day. So on Saturday, the mean was 126 and the standard deviation was 4.1. And on Sunday, the mean was 119 and the standard deviation was 5.8. And we want to use this information to make 2 valid comments comparing the number of visitors on each day. So we've got our mean, and remember, mean is average. So when we're comparing the 2 sets of data, or the 2 means for each of the days, we want to use the word average to demonstrate understanding of what mean is. So we can say the average number of visitors was higher on Saturday. And it's the average, rather than just saying the mean of visitors was higher on Saturday, we have to use the word average or a similar adjective. Now, for the standard deviation comparison, our standard deviation was 4.1 for Saturday, and our standard deviation was 5.8. And the word that we're going to use to compare standard deviation is the variation. So the variation of the number of visitors was lower on Saturday. And the key word there is using variation rather than using standard deviation.